Hola amigos, saludos. Since you landed here, uh, we I'll try my best to teach you trigonometry. Trigonometry is derived from Greek word trigonon means triangle, metron measure, and trigonometry is notoriously known for using Greek letters. Some of them as below: alpha, beta, gamma, delta, theta, lambda. Typically, we measure angle using Greek letters. So I'm just give you a small analogy. Okay. We call this guy Mr. Alpha, Dr. Alpha. He has a PhD. I don't know what PhD he has, but he has some PhD. Say PhD in mathematics. Dr. Alpha. He visits London, Westminster, and he's curious to see, like he's curious to view how tall this Big Ben is. Big Ben is the clock tower in London. Okay, because he has to view the top of the tower, and he has to view up. He has to elevate his chin. So this is the theta, which he's viewing the angle. This is called angle of elevation. Okay, remember, opposite to theta is always opposite to the angle of his elevation. His viewing is called opposite. This is opposite side. Understand? Say for an example, if Mr. Alpha is on the top of the tower, he's viewing down. If this was angle of elevation, alpha, then this becomes opposite. Remember this. And this becomes adjacent. So opposite is always opposite to angle of context, like what angle of elevation or depression. Okay. Now let's recall the famous Pythagoras theorem, because whenever you see a right angle triangle, first thing comes to mind is Pythagoras theorem. Pythagoras theorem is a square plus b square is c square. Okay. Instead of a square plus b square plus c square, we can also rephrase this using the sides above. Opposite square plus adjacent square is hypotenuse square. This is more descriptive than this. So going forward in my tutorials, I'm going to use this. Opposite square plus adjacent square is hypotenuse square. Now, in trigonometry, these sides, they opposite, adjacent, hypotenuse, they define certain ratios. So let's go and put a grid. I'm going to put a grid and define all the ratios here. Okay, remember this. I would rather suggest you to memorize this. Sin theta. What is sin theta? Sin theta is opposite over hypotenuse. So what it means is, for any given right angle triangle, this ratio, opposite over hypotenuse, this is opposite. Opposite over hypotenuse is called sin theta. Likewise, cos theta is adjacent over hypotenuse. Tan theta is the ratio of sin theta over cos theta. Sin theta divided by cos theta. If you divide two fractions, I'm going to do it on the side. Typically, when you divide two fractions, say for an example, 5 divided by 4, 3 divided by 4. The 4 cancels. Why do they cancel? That's like, because when it goes up, kind of flips up. 5 by 4 times 4 by 3 is 5 by 3. So now, in this case, sine over cos, hypotenuse and hypotenuse would cancel off. So it will be opposite over adjacent. Okay, it doesn't stop here, right? If you are familiar, I hope you are familiar with what is reciprocal. Reciprocal means it's upside down, like multiplicative identity. Say for an example, reciprocal of 5 is 1 over 5. Likewise, reciprocal of 4 over 5 is 5 over 4. Remember this, it flips. So ultimately when you multiply them both, it becomes 1, right? 5 times 1 over 5 is 1. Okay, now reciprocal of sine is called as cosecant. Either it is written as CSC or sometimes cosec. Cosec is reciprocal of sine, which is 1 over sine. 1 over sine theta. Then this flips hypotenuse over opposite. Likewise, secant theta is 1 over cos theta. Hypotenuse over adjacent. Then reciprocal of tan is called as cot theta. Cot theta is 1 by tan theta. What is 1 by tan theta? Adjacent over opposite. There is a fancy mnemonic called SOHCAHTOA. Sine opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. To easily remember this entire ratio, I would rather just memorize these, so it's faster, because we use a lot of this in all aspects of physics. You use extensively in calculus, integral calculus, differential calculus, etc., etc. So I would just spend some time memorize these. Okay. Now, also memorize the standard. Say you take a right angle triangle, right? So what they did is they took various angles of theta, say for an example 0, 30, 45, 60, 90, etc., etc., and they found the different ratios, how much the ratios equivalent to. So I'm going to put it on a grid. I hope you memorize this too. Don't rely on a calculator, just memorize these standard values. That way you can do it with mathematics a little faster. Okay, I'm going to put the grid here, right? 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Sine. Sine 0 is 0, sine 30 is half, sine 45 1 by root 2, root 3 by 2, sine 90 is 1. Cos. Cos 0 is 1, it going backwards. Root 3 by 2, 1 by root 2, half, 90 is 0. Tan. Tan is sine over cos. 0 by 1 is 0. This is 1 by root 3. Cancel off 1. Root 3. This is undefined. This one, this table, I suggest you to remember this. Now let's go back. Let's rewrite the Pythagoras theorem. Opposite square plus adjacent square equal to hypotenuse square. Okay, this is an equation, simple equation. Now go back to the definition of sine theta. Sine theta is opposite over hypotenuse. So from this equation, I can write opposite equal to cross multiply. Bring this here. Hypotenuse times sine theta. Likewise, adjacent will be hypotenuse times cos theta, because the definition of cos theta is adjacent over hypotenuse. This cross multiply. Now what I'm going to do is, if you look closely, this is one equation, this is another equation, this is a three equation. What we are trying to do is solving simultaneous equations. We will substitute this via substitution. We're going to substitute, instead of opposite, we're going to substitute here. Bring it here, bring this here. Let's see what happens. We're just curious, what happens if you put this inside this. Let's see. Okay, now come back. Opposite square would be hypotenuse times sine theta whole square, plus adjacent will be hypotenuse times cos theta whole square equal to hypotenuse square. I'm going to apply this inside. So hyp square sine square theta plus hyp square cos square theta equal to hyp square. Okay, let me stop you here. What did I do? I didn't do any black magic. If you look closely, sine theta whole square. Sine theta whole square. You write this as sine square theta, because sine theta is a ratio. The value of sine theta could be half, 1/3, 1/5, 1/7, etc., etc. When you square it, that you just square the ratio, right? Half square will be 1/4. So when you square, this is how you write it. Sine theta whole square is written as sine square theta. It's not written as sine square theta square. Remember, this is wrong. No. Likewise, if I want to cube, cot theta whole cube would be cot cube theta. Remember this, right? Okay. Now, coming back to this original equation, hypotenuse square. Hypotenuse square is common across all of these. So I can take hypotenuse square as the greatest common factor. So I'm left with sine square theta, cos square theta equal to hyp square. I can divide hyp square throughout. So I'll get rid of hyp square. Cancel, 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 cancel. So what our equation, the Pythagoras equation, transformed into a simple sine square theta plus cos square theta equal to 1. In a nutshell, this is also a Pythagoras theorem, right? Because from Pythagoras theorem, we are rewriting the Pythagoras theorem in a different lingo with ratios. Sine square theta plus cos square theta is equal to 1. This you have to memorize. Now, because this is an equation, we can move things around. I can express this as 1 minus sine square theta equal to cos square theta. Likewise, 1 minus cos square theta equal to sine square theta. Okay, I'm going to rewrite this equation. Sine square theta plus cos square theta equal to 1. Okay, if you don't like theta, you can always replace with alpha. It's sine square alpha plus cos square alpha equal to 1, right? That's fine. Now, here, I'm just curious. I'm curious to see what will happen if I divide both sides with cos square theta. Why do I have to divide with cos square theta? I just want to express this equation in terms of tan. Let's see what happens. If I divide with cos square theta both sides, cos square theta, cos square theta. So what do we get? This is like a partial fraction applied to both of these. So you split this, sine square theta by cos square theta plus cos square theta by cos square theta equal to 1 by cos square theta. So these two folks cancel off, become 1. Sine over cos. What is sine over cos? Tan. So this resolves to tan square theta plus 1 equal to 1 over cos. Reciprocal of cos is secant square theta. This I'm going to put in a box. Remember, this is very important formula. 1 plus tan square theta equal to secant square theta. Likewise, if I divide the original equation sine square theta plus cos square theta equal to 1, divide both sides with sine square theta, I'll get a different equation. 1 plus cot square theta equal to cosecant square theta. This is one more. Got it? So, okay. Basically, these equations, sometimes we tinker with them. We play around, we move things around. If I look closely, I can express this. This one, 1 plus tan square theta. I can rewrite it. 1 plus tan square theta equal to secant square theta. Right? If I move this here, what do you mean by moving this here? It means I'm just subtracting. What it means internally is I'm subtracting tan square both sides. So tan square cancel. So what the equation resolves to 1 equal to secant square theta minus tan square theta. So always secant square theta minus tan square theta is 1. This also is one important formula. You don't have to memorize it, but basically if you know this original formula, it's just rewriting it again. Likewise, cosecant square theta minus cot square theta is 1. Okay. I'm going to rephrase everything. I'm going to put this in a grid. Okay. And recall all the algebra formulas. Some of the very famous algebra formulas. If you recall, a square minus b square is a plus b times a minus b. This we are expressing a square minus b square as factors. This times this. Likewise, a plus b whole square. A plus b whole square is a square plus b square plus 2ab. Likewise, a minus b whole square is a square plus b square minus 2ab. All these formulas, you must remember them because sometimes we use a lot in simplifying. Okay, and one cool trick is sometimes whenever you add these two, right, a plus b whole square plus a minus b whole square, we get something like this. A plus b whole square plus a minus b whole square is, these two cancel off, 2 times a square plus b square. Likewise, a plus b whole square minus a minus b whole square equal to 4ab. Okay, why are we doing all this? Because we're going to solve some example problems of trigonometry which involves algebraic formulas and its simplification. Okay. Now I'm going to we'll recollect all these formulas and put it in a grid once again. First thing is sine square theta, Pythagoras, plus cos square theta equal to 1. 1 minus sine square theta is cos square theta, right? And 1 minus cos square theta is sine square theta. Remember this. Likewise, 1 plus tan square theta is secant square theta. 1 plus cot square theta is cosecant square theta. Cosecant. This is cosecant. You can rewrite this as secant square theta minus tan square theta is 1. Correct? Cosecant square, my bad. Cosecant square theta minus cot square theta is 1. Okay, recall, what is a square minus b square? A plus b times a minus b. So whenever you see a square minus b square, you can always express this as secant theta plus tan theta, the above equation, a square minus b square, a square minus b square, secant theta plus tan theta times secant theta minus tan theta will be equal to 1. Likewise, cosecant theta plus cot theta, cosecant theta minus cot theta will also be equal to 1. Okay, there are lots of simple algebraic manipulation involved, and lots of questions are in trigonometry. I would give some of the examples. I'll discuss some of them as examples, and I'll give some of them as exercise in the next tutorial. Okay, let's solve some basic derivations. Let's say the question here is simplify. Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. Oi, what is this? Okay, if you look closely, this is a plus b whole square plus a minus b whole square. Okay. You can expand this as well as expand this as a basic algebraic formula. A plus b whole square is a square plus b square plus 2ab. So when you expand this way, the above expression becomes sin theta whole square as sin square theta plus cos square theta plus 2 sin theta cos theta. Likewise, this will be sin square theta plus cos square theta minus 2 sin theta cos theta. This is basic expression. It's not an equation because you don't see any equal to here. So now these two are similar terms but opposite signs, so they cancel off, become 0. Now if you recall, sin square theta plus cos square theta is 1. Likewise, sin square theta plus cos square theta is 1. 1 plus 1 becomes 2. The answer is 2. Okay. If you recall this formula, a plus b whole square plus a minus b whole square equal to 2 times a square plus b square. If you remember this formula, you don't need to expand this whole thing. This would resolve to 2 times a square plus b square. 2 times a square, which is sin square theta, plus cos square theta. Sin square theta plus cos square theta is 1. So this resolves to 2. Okay. Now, this one more formula I want you to remember. A plus b whole square. I'm not sure if I mentioned it earlier. A minus b whole square is 4ab. How? Because when you expand this and subtract a square cancels off, b square cancels off, and you're left with 4ab. Now, based on this, say I can just phrase one small question here. Tan theta plus cot theta whole square minus tan theta minus cot theta whole square. If you remember this formula, you don't even have to expand this. So this becomes 4 times, this is a plus b whole square, a minus b whole square, which is 4ab. 4 times a times b, which is cot theta. Tan and cot are reciprocal of each other, right? When you put side by side, when you multiply them, they always cancel off because tan is 1 by cot. So answer is 4. Remember this. So what I mean is tan theta times cot theta. What is cot theta? Cot theta is 1 over tan theta, right? So what it basically, this is tan theta times 1 over tan theta. These two cancel. Answer is 1. Okay, let me end my lecture here. I'll give more questions and I solve more problems in the next class. Thank you.